looking at the surface area of prisms and cylinders. Now we talked about this yesterday. We kind of they're similar. Hopefully you can tell me why. Well, let's look at this prism first. This one, it has 6 sides. We have a hexagon here that makes this a hexagonal prism. It has 2 bases that are congruent and the rectangles around it. Okay, and here we have a cylinder. Also has 2 bases, but it's always going to be the circle and no rectangles around, but similar looking lateral face on it here. Okay, now the surface area is kind of one step from when we started looking at area. Surface area means we're going to find the area of every face of this figure, everything that's outside. So this one we'll look at second, but we're going to start with our prisms. So the easiest way, or maybe the most straightforward way, is to find the area of each face and add them together. Now we are going to look at a way to put that together into a formula. Maybe you simplify it for you, but it is fine with me if you just, as long as you know in your head, I have to find the area of every single part and add them together. So in this case, we're dealing with, if you guys remember from last chapter, how do we find the area of our hexagon, and then we find each individual rectangle. Here we would find the area of our triangles, the 2 bases, and then the rectangles, this case squares around. And then same thing with our rectangular prism, this cube, we wind up finding the area, whichever one we choose is the base, the area of the 2 squares and the rectangles or squares around. Okay, so let's do one. Let me show you how to break it apart and look at a rectangular prism. Okay, we're pausing for our first question. Please tell me, how is a cylinder like a prism? Okay, here is the first shape we're going to look at. I grabbed a rectangular prism that I had around, and I want to show you, again, you could do each face, find them separately, but let me show you one way to look at that all at once. The first thing you want to do is what we call making a net of the shape. So we're going to open up our box and just look at what the pieces are. Okay, hopefully I can do this pretty quickly. Taped it all together. Alright, so when we open up our box or our rectangular prism, we have the 2 bases, the top and the bottom are going to be my bases, and these are the rectangles around. Okay, so when you look at that, you can see that we have the top and the bottom base, and then our 4 rectangles that go around the base. If you look at where they come from, they go around the base. They're going to open up, and they're technically going to make one big rectangle. We can look at it that way. Now, like I said, you can look at them separately, find this rectangle, the area of this rectangle, this one, this one, this one, this one, and add them all together. And that is fine to do that way. You just have to keep yourself organized, okay? But otherwise, you can look at it this way. We have 2 bases that we know are congruent. So if we find the area of one base, we've got both of them. And then here we can look at this as one big open rectangle and find, we know this length and this length, then we can find the area of that rectangle. So let's see if we can figure this out. When we make this into a box, my rectangle, the lateral faces here that open up, is the height of my rectangular prism, right? That's the height. Now they're also going to give us the width and the length, which is going to make up the area of the bases, right? So let's go ahead and draw this back behind there into what we call a net. So hang in there. Okay, I put my box back together to kind of talk about the dimensions, and I drew the net from the box here, okay? So they might tell you you have a rectangular prism who has a length, a width, and a height, okay, the 3 dimensions of the prism. Alright, so I drew it up here too so we can draw it on here. They tell us that the length is 4, so we would make this 4. The width is 2, and my height is 7. So you can kind of see it on the picture there. I wanted you to see the dimensions on the actual box. So now we want to transfer that to our net. A net is what we call when we open up our three-dimensional figure and lay out all the pieces, the different sides, so we can find their surface area. Okay, so here we go. We had the front of the box was 4 by 2, so that means we have 4 around the side 2, the back was 4, and the other side was 2. So 4, 2, 4, 2. That means the dimension of the bottom was 4 by 2. The top was also 4 by 2. You can write them up there too. And then the last dimension we had was the height of 7. All right. So now if you look at it here, we can find the area of a rectangle. It's pretty straightforward. Base times height. So we can actually figure out each one. 4 times 7, 2 times 7, 4 times 7. Again, the height over here. 2 times 7. That gives us the area of each piece. And then 2 times 4. And we add them up, and that is fine. Just find them all separately. You might find, you go ahead and write it inside. You say, okay, we got 8 here, 2 times 7, 14, 28, 14, 28, and 8. And then you would just add up all the numbers, okay? That would be your surface area. But let's look at it kind of a bigger picture that's going to match the formula that they give you. Let me erase these numbers real quick. Okay, we're ready for question 2. Tell me, what is the net of a solid? How to describe it for me. Okay, we kind of have a clean slate here. I want you to see it with the formula because the formula is what works for every type of prism. So whether this is a rectangle or a triangular prism or a hexagonal prism, and even when we get to the cylinder, the formula stays the same if you think of it in that way. So I want to show you that. Let me just pick a different color here. Alright, so the formula says we're going to deal with, again, you have the same dimensions, but you're going to deal with the two bases, find them separately, and then look at this as one big rectangle, okay? So the formula says, alright, my surface area, and they use capital SA for surface area, equals, we have two bases, so if we find the area of the base of one base, we just multiply it times 2. They say, so alright, we got 2 times the area of the base, that's what the capital B stands for, area of the base, and then we're just going to add the area of this rectangle. So we see here that the length here is 7, that's my height, but how do we find this length here? Now if you think of where it comes from in the box, right, these are the sides that go around the base, okay? So if we can find the perimeter of my base, then I just have, that is the length of the large rectangle. So they write it as a capital P for perimeter times the height. That is the formula for surface area. All right, let's see if we have room to kind of work this somewhere. So they say, all right, we've got 2 times the area of the base. We know the one base is 2 times 4, which is 8, length times width, base times height. So we say, all right, 2 times 8. And then my perimeter, we're just going to add these across here, 2 plus 4 plus 2 plus 4. So we have 12 times my height of 7. And we're going to put these together. 16 plus 12 times 7. What one is that one? That is 84, I hope. We're going to add that together to give us 100. Nice. All right, and that is our surface area of this box right here. Okay, let's do another one with a different type of prism using our formula, but also kind of look at it, breaking it apart, but let's draw another one. Okay, let's look at our next figure. This is one I showed you the other day. It's a triangular prism. Bases are triangles, rectangles around the outside, and we drew it up here. I measured it, it's 8 inches tall, and the triangle is an equilateral triangle, 1 inch all the way around. So let's open this one up and see what it looks like. Right? It's gonna open up similarly. We're gonna have the two bases, the top and the bottom. We kind of open them up here, but this time, notice because we have, get this open, because we have triangles on the bases, we're going to have 3 rectangles instead of 4, which makes sense, right? Okay, it's supposed to be easier than this. There we go. Okay, so we open it up. Hard to see that way. Let's turn it around so you can see my 2 bases are going to stand out here at the top, and the 3 rectangles that connect to each side of the triangle are right there. Let's go ahead and draw one of these. Actually, it stands there nicely while we get my marker. Okay, I'm going to kind of trace it here. Got some tape there I'll have to deal with. Alright, so when you open it up, there we go. We're going to wind up with 2 triangles connected there. I'm going to do this without my ruler, so it's going to be a little bit of a sketch. There we go, but same deal, right? Alright, and we said that the dimensions happen to be my triangle. Each side of my triangle is 1 because it's equilateral, and my height is 8 inches. Alright, so because my triangle has 1 inch, each one of my rectangles is going to be 1 inch across as well. So here again, we can find our rectangle by finding 1 times 8. Each one of these is 8. You can add them to, then we have to find the area of our triangle. So there's sometimes the base is going to give you that little hard, the hard part of the problem, because it's not going to be straight base times height. So let's see if we remember how to find the area of our triangle. Let's make it bigger here. Equilateral triangle, each side is 1. We need to find the height of our triangle to find the area, right? So let's go ahead. We have this one is 0.5. It is a 30, 60, 90, which is nice. If you guys remember, or you can use the Pythagorean theorem, we cut it in half when our altitude cuts it in half. But because it's 30, 60, 90, this is half of the 1, and then this is going to be 0.5. It's going to be too small. 0.5 times the square root of 3. We'll work that out in our calculator when we get to it. But so you can find the area of the one triangle using 1/2 base times height. And we have here our base is 1, 1/2 times 1, and then times 0.5 times the square root of 3. Alright? Alright, so let's look at that. I'm going to grab my calculator, and then we're going to look at it using our formula. But here we would take the area of one triangle plus again, and then add the rectangles. Hang in there. Okay, I'm back. Let's go ahead and multiply this across here. We've got 1/2 times 1 times 1/2 again times the square root of 3. And we wind up with 0.43. That is the area of my rectangle. Would be inches, what we're dealing with. Okay, and again, you can add them all separately. Let's look at our formula. Remember, the surface area is 2 times area of the base, that big old B, plus the perimeter of my base. In this case, it's just 1 plus 2 plus 3 times the height of my figure. So we have found out the area of the base is 0.43, so it's going to be 2 times 0.43. The perimeter of my base is 3 times my height, 8. So let's work this out. 2 times 0.43 would give us 0.86, plus 3 times 8 is 24. You just add those together, 24.86, and that is the surface area of the whole figure. Again, using the formula versus you can do it separately. I'm really fine with that. Just kind of want to introduce that to you because we are going to use it, and it kind of makes sense when you're dealing with different bases, and then now with the cylinder. So let's look at a cylinder. Alright, the next shape we're going to look at is a cylinder. You can see my little can of green beans here. Hopefully you will see as we do this one, as we open it up, why we put these two together. Okay, I went ahead and drew a picture of my can. It's not exactly the same, but it has the right measurements. I measured the can. It's 11 centimeters high, 7.5 centimeters in diameter. Remember, when they point to the little center part, they're talking about the whole diameter, especially when they draw it all the way across, so watch out for this. Alright, the first thing I wanted to show you was, obviously, have the two bases here. We can't quite open up the can like we did a box, but hopefully you can imagine the two circles come out. But what is interesting, and you can see it with the label of the can, when I cut this label straight up and down and open it up, hopefully you can see that actually the figure, that face around the can, is a rectangle. Okay, so this is why we can use that same formula. Okay, let's go ahead and draw my can. We've got a nice rectangle here. We have the length, oh, that's terrible. Let's try to do a little bit better job here. My rectangle, height of 11. So the question though is, can you tell me, of this nice big rectangle, I'm going to put my can top and bottom, and that's also terrible. Let's make it a little bit bigger. Okay, pretend they look the same. Those are the two bases here. We know that from our dimensions, we measured that the diameter is 7.5 right here, and we know that the height is 11, but we're missing that one piece of my rectangle. Okay, so where do you think we get the base of my rectangle from? And hopefully you will see that when I wrap the label back around, it goes all the way around the circle. Okay, so the length of this rectangle is really just the circumference of the circle, because it wraps around exactly. Alright, so we're going to have to do a little bit of figuring. This one's going to be 2 pi r, or in this case we're going to use pi d, because they gave us a diameter, so we know it's actually 7.5 times pi. Alright, so this time it matches our formula a little better. We find the area using the same formula. Surface area equals 2 times the area of the base plus the length, or base times height. They go ahead and put in, it's going to be 2 pi r, the circumference times my height. Okay, so it's a little bit different, but really it's that base, or the perimeter, I guess we put it that way, the perimeter of my base, which in this case would be the circumference, times the height. So it's similar, but just slightly different because the shape is different. Alright, so in this case we have 2 times the area of the base. We need to do pi r squared. Let's go ahead and find it over here. Area of my circle, pi r squared. We're going to have to cut my 7.5 centimeters in half, time and square it. So 7.5 divided by 2, we get 3.75. And remember, we only square the number, not the pi. Go ahead and do that first. 3.75 squared is about 14.06 times, and we're going to go ahead and get rid of pi for now because we have to add it to some other numbers here. Divided with 44.18. That is a measure of one circle. So in our formula we have 2 times the area of the circle, so it would be 2 times 44.18. The circumference, when we go back up here, it's 7.5 times pi. Let's go ahead and use our numbers. It's about 23.56. So we're going to do 23.56 times my height of 11. Alright, let's put that all together. 2 times 44.18 gives me 88.36. 23.56 times 11, 259.16. When we add them together, we get 347.52. I did measure them in centimeters. Since it's area, it is going to be centimeters squared if they give you some units there. Okay? I'm going to hesitate. I'm not going to do another one just because length of time. but we can go over them in our Zoom class if you want to do a few, but give them a try. The formula, hopefully it kind of keeps it organized for you, but if you like to do them separately, really, that is fine. Just the base on this one, it is still the perimeter of your base, but it winds up being circumference because our bases are circles. Okay. Alright, hopefully you guys have a better understanding of surface area with prisms and cylinders. Give them a try. I know sometimes they take a little while, but hopefully I didn't give you too many this time. Tried not to. And then we'll go over them the next day in your Zoom class. Okay, if you have any questions. Let's look at your joke of the day. What do farmers use to make crop circles? They use protractors. Okay. Hopefully you guys have a good day, and we'll see you soon.